Hello everyone, my name is Song Wei. I'm come from Xuzhou University of Technology. It is with great pleasure that I'm presenting this talk today in the RGF 26. The focus of my talk will be on the fatigue crack growth investigation of high-strength steel welded joint considering the stress ratio. I'd like to acknowledge the support of the founding and the fundamental agency and the industry partners. This particular presentation is analyzing the basic fracture properties of a high-strength steel and its uh, weldment, considering the stress ratio. But as the part of the larger project of design, the analysis as well as manufacturing the ship and submarine welded components. So this presentation contains four parts. The first one is about the motivation of our investigation. The second is about the fatigue crack growth ratio experiments. Third is about the result of the fatigue crack growth. The fourth is about the conclusion. Some background and motivations for the work, as many as you may know, within future industry development. One of effective way to enhance the lightweight of structure is to increase the strength of steel for decreasing the thickness of the plane. It is dealing with a conventional material. How about the structural performance, especially for the welded components? For example, there is no corresponding welded filler or high-strength steel or very high-strength steel in our country. However, these components, which are driven by the cyclic loading or fatigue loading, there is a unique opportunity to utilize the high-strength steel and investigate the performance of the specific welded joint weldment. So in the shipbuilding or marine structure fields, this uh, welded is very common. So for the welded joints of high-strength steel, there are some problems during the welding processing or the service condition. The first one, the high strength hydrogen induced the cracking issues or the softening of the HAD and the decline of the softness. How to solve the problems? We can do from two aspects. One is to solve the problem by the welding processing, just like the lower the energy of preheating the welded plan, or do the post head treatment after the welding. Another way is to using the welded materials. So for this, from this way, we can obtain the mismatched welded joint of a high-strength steel. So how about the fatigue crack growth behavior? So uh, this is the topic of our presentation, our work. Saying, thus, the study aims at investigating the FCG properties of base metal and mismatched weldments. The second is the stress ratio and post-head inverted treatment effect on the FCGR of materials. The third is the FCGR mechanism of the of the base metal and the mismatched weldment. In future, the post application of this study, the first aspect is about the improved the FCG uh, fatigue crack propagation life prediction of the welded joint, um, and the mechanism of FCGR is analysis through crack paths in the microstructures and the fractal graph. This is the basic mechanical properties of the materials. So the parameters of the materials are presented in the summary. We get the CT specimens uh, from the stick welded plane, which is made by the multi-pass welding processing. The details by which the experimental investigation to characterize both the welded joint and the properties were conducted as follows. It should be noted that the test frequency range from 10 Hz to 15 Hz for all the FCGR tests and conducted by using the several hydraulic controlled load frames. And the three stress ratios are loaded in the test, and the crack propagation length is 25, which is defined as the failure criterion. So this is the machine of the FCGR test. The FCGR result is presented in this page. We compared the base metal and even matched weldment and undermatched weldment and the residual stress 0.1. So from the result, we can see the FCGR comparison between the S-weld and the PWHT steps were conducted for these materials. And the FCGR of base metal isn't influenced by the PWHT processing in the first figures. Which means that no residual stress effect on the FCGR in BM in base metal. The FCG data on the base metal compared with the BS 7901 and the IW standard simplifies the Paris law reference lines. And it can be seen from the unmatched development figures that the difference between the as welded and the PWHT state for the unmatched seems no significant effect on the FCGR data and the stress ratio 0.1. So the FCGR data are summarized in this figure for these three materials. And the material mismatch and the PHWT effects have obviously influence on the FCGR data and the CT specimen and the first ratio. Although some articles report that the R ratio is essential is sensitivity in some high strength steel materials or braid structure steels, the R ratio effect of on the FCGR data of our study uh, are visible, especially for the even matched development. It also can be observed that the FCGR in the BM and the WM become faster and the R ratio increased, which is consistent with the consensus on the R ratio effect for most metallic material. So the material R ratio have obvious influence on the on the FCGR data of CT specimen for base metal, undermatched weldment and even matched weldment. As we all know, the restore stress has great influence on the FCGR behavior. Generally, the tension restore stress will illustrate to the FCGR, and the comprehensive restore stress will redundant to the FCGR fatigue crack propagation. Looking at the restore stress distribution of the even matched weldment and undermatched weldment, considering the SSPT effect. So the result showing that for the even matched weldment, the simulation result is has good agreement with the experimental data considering the SSPT effect. However, for the undermatched weldment, the restore stress distribution of has great has has great the agreement for both of the for both the considering the SSPT effect or no SSPT effect. So the residual stress of the even much and under much development or better considering the SPD effect, which is a significant influence on the even much FCGR. This figure shows different scales of optical micrograph of the crack path of embodiment for the CT specimen. As we can see from the comparison uh, between the even matched and unmatched embodiment, uh, the even matched weldment overall crack growth path is smoother than the unmatched weldment. The fracture crack of even matched passes through the mixed benefit and cross grained inferior material grains, which result in small crack deflection. So from between from the ABSD and the KM map, which showing the plasticity uh, uh, deformation. So this results show different characterized results um, between the even matched and the undermatched weldment. The fracture morphologies of even matched and undermatched specimens under these regimes by two different specific magnifications. The damples on the fracture structure, the damples on the fracture structure of even matched specimens are deeper than the unmarked weldment specimens, showing the typically ductile morphology for the metallic materials. It further indicates that the even matched weldment has strong plastic deformation ability than the unmatched weldment. Okay, so the last section. The conclusion contains 4 points. The first one is that for the low ratio, the unmatched demonstrate high residual stress FCGR curves than in the base metal or even matched weldment. There is no significant difference between FCGR for even matched and undermatched weldment between high ratio. The second one is that the two different fracture mechanisms are exhibited for development. The transgular fracture appearances were showing on even matched development, while the intergranular fracture surface were observed on the Mars development. The third is the FCGR under the aspirated state is slightly lower than the PWHD state, attributed to the tension residual stress effect on the fatigue crack tip. The fourth is that according to the KM analysis, the plastic deformation in the crack extension illustrate regime is higher than the initial and the stable stage for both uh, even much than the advanced development by comparison with the three different crack growth regimes. Thank you for your attention.